turn it on, it'll be putting out whatever percent is written on there. So then what happens is our oxygen is going to come up here, pick up inhalant if it's turned on. We've got tubing that's going to run down through here. We can't see it because can't see really where the tubing's going. It's underneath here, but it's going to come out right here. Okay, so this is where our oxygen and our inhalant, if it's turned on, is going to come out right here. And this is going to flow all the way over to here. So you can see that it's just kind of flowing along through here. So for our low pressure breathing system, we would consider this to be our fresh gas inlet. So this is where our fresh gas is entering our breathing system. Okay? So then, if we just back up just a moment before we get into our breathing system, there's another way to deliver oxygen to the system. So the one way is through this flow meter. So the other way that we can deliver oxygen other than from our flow meter is through the oxygen flow valve. So if I push this, you might be able to hear, sounds like a very high flow of oxygen, which is what it is. So what happens is when I push this, it opens a valve which allows the oxygen to bypass the flow meter and bypass the vaporizer. And it's essentially going to come down here and enter this system down right here. But it'll enter it at a very high flow rate. And the idea is to deliver oxygen quickly without any inhalant in it. And there's times in anesthesia you might want to do that. We use that a lot when we're doing our pressure check of our breathing system, as you'll see shortly. So the O2 flush valve is going to bypass the oxygen flow meter, is going to bypass the vaporizer and deliver 100% oxygen. The flush valves are located somewhere on the front. Sometimes they're obvious. This one's pretty obvious. Over on this machine, the flush valve's kind of a tiny little thing. That's a little bit harder to see, but that's it right there, the oxygen flush valve. Okay. So now we have our oxygen being delivered to our system, and so we'll talk about that system. And first, let me just set up a couple of things. There's a couple of things that we're going to set up. One is our corrugated tubing. So this is our corrugated tubing. And we have two sides of the corrugated tubing, and it's just held together by what we call the Y piece. So this Y piece right here is what we're going to use to connect to our patient's endotracheal tube. These other ends are just going to hook in right here. And it doesn't matter which side you hook up to which side because it's just tubing. Okay, so we have our corrugated tubing and our Y piece hooked up at this point. Just hang that there for a second. And then we're going to pick our rebreathing or reservoir bag for our patients. We have a number of sizes. In this case, we have a 1 liter and a 3 liter bag, which we'll pick depending upon the size of our patient. And so that's going to go right here. Okay, so now we have our system set up. So one of the first things we want you to be able to do is to identify the components of the breathing system. In this case, we're working with a rebreathing type of system because oxygen will go around and around and be reused in the system. And it's referred to as a rebreathing or circle system. So to start with, we'll go back to where we have our fresh gas coming into our system, which we had said was right there. We have two one-way valves. Right above here is our inspiratory valve. And this is our expiratory valve. And you can see the expiratory valve is labeled. So we have inspiratory and expiratory valves. These two one-way valves are what causes the gas to move in a single direction so that our patient cannot rebreathe carbon dioxide. So we have our two rebreathing valves. We have what's known as a pop-off valve right here, which I can close by either pushing in, so I can close it temporarily, or I can close it all the way by turning it clockwise. So this is what allows excess gas to leave the system. And when it's open like this, excess gas will leave the system out the back of the machine. Okay, and once it goes through the pop-off valve, which will be leaving that way, then it has left the breathing system and has entered the scavenging system. And we'll look at that scavenging system in a couple of minutes. So this is our pop-off valve. We also have the rebreathing bag, which I talked about. And then we also down here have our CO2 absorbent. So this canister has CO2 absorbent, which is usually Barolime or Carbolime or Soda Lime. So there's a variety of products that can be used in here. And the purpose of these products is to take CO2 out of the gas so that the rest of the gas can be reused and rebreathed by the patient. So that's our CO2 absorbent. And then we also have another gauge up here, and that is the pressure within our breathing system. That pressure is measured in centimeters of water, and typically would be somewhere between 0 and 2 centimeters of water when the patient is hooked up to our system. So we always want to make sure that we have low pressure in the system. So just running through those again, we have our fresh gas inlet, our inspiratory and expiratory valves, our corrugated tubing, our Y-piece, our pop-off valve, our reservoir bag, and our pressure gauge or pressure manometer. Those are the components of the circle breathing system. So when we have this all hooked up like this, one of the things we want to think about is, well, how does gas flow through the system? And it's not intuitive because a lot of the tubing is hidden by the shelf right here. So the gas, as I mentioned before, is going to come through our flow meter, through the vaporizer if it's turned on, and it'll come down here, along here, and will enter our system here. So somewhat arbitrarily, this is the start of our breathing system, our fresh gas inlet. The gas is going to go through our one-way inspiratory valve, go out the corrugated tubing, through the Y-piece to our patient. When the patient breathes out, they can only breathe out along this side because of this one-way valve, they cannot breathe out on the side that they just breathed in from. So the exhaled gas can only go on the other side. It'll come along here and go through this valve right here. Once it goes through this valve, it can either leave out the back of the machine if the pop-off valve is open, or it will come down and come through our CO2 absorbent. So it either leaves the system or comes down into our CO2 absorbent. And when it comes down, it's going to collect and come back up here through this pipe. While our patient is exhaling and waiting to take the next breath, the gas is going to come along here, over here, and into here. And it's just going to sit here waiting for the patient to take a breath in. This gas has already gone through the CO2 absorbent, so there's no carbon dioxide in the gas in this bag. So the CO2 has been taken out. Now our patient takes a breath in. The gas is just moving along pressure gradients. It's going to come back here, here, up this way through the one-way valve, and it's going to combine with more fresh gas coming in and start to retrace those steps that it took before. Okay? So that's the flow of gas through the system. The higher our oxygen flow is relative to the patient's needs, the more of that gas will go out through the pop-off valve into the scavenger after it's gone through the expiratory valve. Let me just turn this machine around to show you where that's happening. So this is where our scavenger, this is where our waste gas is coming out, right here. And we've hooked up our scavenger system right to it, and so it's going to go into this tank right here. Once it hits here, it's just passively going through this copper pipe and is being deposited at the bottom of this PVC pipe. You can see from the bottom here, we have that white tubing, which is our scavenger system. At the bottom of this PVC pipe, we have active scavenger or active suction going on. So this is pulling out the gas that's been passively delivered down here. It's been scavenged. So it's heading out this way, out through the ceiling to wherever it goes, away from here. You'll notice on our system right here that it's kind of big. And Reason for that is when you're moving from place to place with an anesthetized patient, you're no longer hooked up to the active scavenge system. So this serves as a reservoir to collect that gas, that exhaled gas, so you don't breathe it. And then when you get to your destination, you hook up your white tubing to the vacuum system again and get that scavenge out. You'll also notice there's some holes at the top here of this PVC pipe. And the reason for that is when you go to a certain location, the scavenge that's occurring at the bottom down here at the end of this, at the bottom, may be kind of strong for the amount of gas being produced. So this will just pull in room air to equalize that pressure rather than pulling the excess gas out of our breathing system. So that's our scavenger system. Okay, coming back to the front here, we've covered the component parts that are all up front here. We've talked about the oxygen flow of gas, or the flow of gas through our circle breathing system. And now we're going to talk about how we pressure check our breathing system before we use it, because we always want to make sure that there's no big leaks in the system. So first of all, I'm just going to put my thumb over the end of my Y piece. I'm going to close the pop-off valve. Now I have to fill the system with oxygen and pressurize it. I can either do that by turning on my O2 flow, or I can push my oxygen flush valve. You can see the bag is getting bigger. And I want to come up here on this pressure gauge somewhere above 20 centimeters of water. So somewhere between 20 and 30 centimeters of water is where I want to be. And now I'm just going to hold this pressure. There's no oxygen flowing in my flow meter, but I'm just holding everything here for about 30 seconds. So I'm looking to see if there's any drop in that needle during that 30-second period. Sometimes the drops occur quickly, sometimes they occur a little bit slower, so that's why we want to give a little bit of time to see if there's any leaks. I'm not seeing any leaks right here, so that's good. So now my next step is to open the pop-off valve. And to watch the pressure decline. So it's gone back down to 0. And now I can take my thumb off the end. So that's a pressure check, which has turned out just fine with no leaks. Now, it's really important to go back to that idea of how do I let the pressure off the system. So if I go back to pressure checking, close my pop-off valve, I have my thumb over the end here, I inflated my bag, I've developed the pressure that I want, I've waited 30 seconds, and now I don't just pull my thumb off the end here, I'm opening my pop-off valve. There's two reasons for that. One is I want to make sure my pop-off valve is working. I want to make sure my pop-off valve will release pressure when it's supposed to be. The other is, theoretically at least, if I just release my thumb, then that pressure change could kick some dust from the soda line up into my rebreathing bag area here, and our patient could eventually inhale that. So we don't want that to happen. So we want to release pressure through the pop-off valve at the end of that pressure change. Okay, so that's everything with the circle breathing system. We just take this off right here, and now we're going to move on to the non-rebreathing system. So the non-rebreathing system we use for patients generally less than about 5 kilos. And we use the non-rebreathing system because of the fact that there's less resistance to gas flow. So in the circle system, our patient has to be able to move the one-way valves that are in here, and they have to be able to move the gas through this CO2 absorbent. Well, little tiny patients, especially when they get down to 1 or 2 kilos, often don't have that ability to do that. So we want to use a system that doesn't rely on one-way valves. And we tend to use what's known as a Bain system. And this looks a little unwieldy, but the Bain systems come in different lengths. And so you see that there's a tubing that comes along here, and then it runs on the inside of the corrugated tubing. So we have a tube within a tube. And this inner blue tube ends right about here, and that's delivering our fresh gas. So when we're looking at this and trying to figure out how to hook it up to the patient, the end that is furthest away from where this fresh gas comes in is where we hook up our patient. So this end right here is the end that would be connected to our patient's endotracheal tube. Okay. So we have a little adapter here that usually lives in the drawer at the bottom, and it has a little opening here. So I'm just going to put that right there. So that just sits on right there. I'm going to hook up this far end right here. And again, this is the end that goes to my patient. Put that there for a moment. Okay, I've got a rebreathing bag, and I can just take my small rebreathing bag that we had before, our 1 liter rebreathing bag. Put that right down here. Get that right down here. Now I have to hook up my fresh gas because I need to have fresh gas here. So we go back to where we were before, where we had our fresh gas comes down here, up here to our circle system, and you'll notice there's a little connector here. So I'm going to pull that apart and use that to connect the fresh gas right there. So now we have fresh gas that's going to come in. I want to make sure my pop-off valve is open, so this pop-off valve always has to be open. And then one more thing I need to do is to move my scavenger. So this is where my scavenger came out. My scavenging tube came out for the circle breathing system, but we're not using that system anymore. So I'm going to take this, kind of thread it underneath here, and it's connecting right down there. So now we have our system all hooked up.